Okay. Hello, my dear future chartered accountants. Hope everybody is doing great. Good evening, good afternoon, good morning, everything. First of all, can you please confirm that my voice is audible and the PPT is visible? Yes? Okay. Thank you. Okay. So we were discussing probability chapter. We discussed till few illustrations. Let's move on. I think we have to do this one, right? I think the previous one we finished. Yeah, I think this we finished. Let's do this one. The odds in favor of an event is 2 is to 3. Odds against another event is 3 is to 7. Find the probability that at least one of the two events occurs. At least one of them means probability of A union B. You can do it in two ways. First, let me do a regular one. Probability of A plus probability of B minus probability of A intersection B. Probability of event A, odds in favor, 2 is to 3. Odds in favor means the first number is favorable, second number is against. So 2 is to 3. So 2 possibilities are favorable out of total 5 possibilities. So probability is 2 by 3. Odds against another event is 3 is to 7. Odds against means the first number represents favorable, the second number represents against. Sorry, the first number is against, second number is favorable. So we need the second number which is favorable, which is 7 by total possibility 7 plus 3, which is 10. Minus intersection, when nothing is given, you know the two events will be taken as independent events and the intersection can be calculated by multiplying the probabilities. So 2 by 5 into 7 by 10, and that will give 2 by 5 is 0.4. This is 0.7. 2 by 5 into 7 by 10, 0.28. So this should give you 0.4 plus 0.7 minus 0.28, 0.8. So 0.82 is the answer. Please check. In some material, printing might not have happened as 0.82. Please check your material. You have 0.82 as option D in your answer. Please confirm. Is it fine in the material? 0.82, option D. Yes. Okay. Very good. Thank you. Can we do it as probability of A B complement plus A complement B plus probability of A B? You can write. When something is straightforward, you want to go like this. Yes, A B complement, that means A only, A complement B, B only, A B, A and B. Yes, you can try, you get the same answer. Okay, but there is one more popular method we used to do. Let me show you that also quickly. That is probability of at least one can be written as 1 minus probability of none of them. Complement method. A union B is 1 minus none of them, neither of them. Probability of either is 1 minus probability of neither, using that method. So 1 minus probability of none of them. That means first person also fails, second person also fails, both event fails. So 2 is to 3. So unfavorable event, against event is 3 out of 5, and 3 is to 7, and here first number itself is against. So 3 by 7, which is 1 minus 3 by 5 into 3 by 7. So not 3 by 7, 3 by 10. Not 3 by 7, 3 by 10. You have to add it. This is a mistake can happen. You have to add it, 3 by 10. 3 by 5 into 3 by 10, 0.18. So 1 minus 0.18 You get the same answer, 0.8. Okay, let's go further. The odds in favor of an event is 2 is to 3. Odds against another event is 3 is to 7. Same data as previous one. Find the probability that only one of the event occurs. This is interesting. Only one of the events. Which means if A happens, B should not happen. And if B happens, A should not happen. That is basically we want a probability of only one of them. Only one of the two events, not both of them, only one of them should occur, which means we should say probability of A intersection B complement, which means only A and B does not happen, or so we can do plus only B happens, so probability of A complement intersection B, that is only B. That's the meaning of only one of the two events. Both of them cannot happen. Or if I represent by Venn diagram, this common area, intersection, this region, which is in A, but does not include the common region, that is what we say only A. If I say this is event A and this yellow region represents only A, that's what probability of A intersection B complement. Similarly, only B, I'll use different colors. This one, inside this region, that is only this. Or you can also do from the union set, if I take out the intersection, that also will give you. First, let's calculate this one. Probability of a intersection B complement using the independent events. I can write it as probability of A into probability of B complement, or so plus probability of A complement into intersection, because independent events we can multiply it by probability of B. So what is probability of A? 2 is to 3, so 2 by 5. B complement, 3 is to 7, 3 is anyway against, so 3 by 10. Plus A complement, that is the other one, against number, 3 by 5. Probability of B, that is B happening, second number, 7 by 10. So you get 6 by 50, you get 21 by 50. If I take LCM common, 27 by 50. I think you get 0.54. I think 0.54 is the answer. Yes, 0.54. Again, more than probability, these are depending on your set theory more. But anyway, even if you don't have set theory knowledge, by looking at the graph and this explanation, you should be able to understand. If you have any doubt, you can still ask me. Okay, hope it is done. You can also do it in one more manner I told you. We can also do, you understand, this is what is inside both the circles, but the common area is I am taking it out. Why common area is I am taking it out? Because they said only one of the two events. Both the events cannot happen simultaneously. Both the events means intersection. So that I should not consider. In intersection, both event happens. I don't want that. Either first event or second event. So basically from the union set, I take out the intersection. So this I can also write it as only one of them. I can also write it as probability of A union B, either of them. From that both of them I take it out. Intersection I take it out. That is probability of A intersection B. And what is A union B? We have calculated in the previous problem, 0.82. A union B is 0.82. Intersection also we calculated previously only. 0.28, right? We multiplied both and we got it, 0.28. So 0.82 minus 0.28. That also will give you same answer, 0.54, same as this one. So you can write down this alternative also for your reference, and any doubts, please get clarified. Is it done? Any doubts? Okay, I'll go further. Since I'm not getting any question, I assume you have done it. There are three boxes with the following composition. Box 1, 7 red, 5 white, 4 blue balls. Box 2, 5 red, 6 white, 3 blue balls. Box 3, 4 red, 3 white, 2 blue balls. One of the box is selected at random and a ball is drawn from it. Two events are there. Whenever it is and we multiply. Keep it in mind. What's the probability? The ball is red. Now please tell me from which box you are selecting the red ball. You may select from the first box, and in that case probability of red selection is different. You may select the second box, the probability of selection is different. Or you may select the third box and probability of selection is different. So how are you going to write it? You use the conditional probability, but not the formula, just the concept. First, one of the box is selected. Which box? Any box, which means what is possibility 1? First box is selected and you select a red one. Select red ball. Okay? Or possibility 2, you select second box and a red ball is selected. Or possibility 3, third box is selected and a red ball is selected. So when you read a question, see if you are able to convert this into a statement format like this, combination like this. First box is selected and then you select a red one. Or you select a second box and then you draw a red one. Or you select the third box and then you draw the red one. Because ultimately you have to select the red ball. That is the probability requirement. Okay. Now, what is the probability you select the first box? Can one of you give me the probability? What is the probability of selecting a first box? And then you go for red ball. First of all, you select a box. What is the probability of selecting a box? First box. 3 boxes are there. So 1 by 3, isn't it? That's all. 3 boxes are there. 1 by 3. 5 candidates are there. Probability 1 by 5. Random experiment. All are equal events. And means multiply. Now selecting a red ball. 7 plus totally how much? 7 plus 5, 12. 12 plus 4, 16. So 7 by 16. And so we multiplied. Then OR means plus. Second box selection 1 by 3. Red ball, in this case 5. Total 5, 6, 11. 11 plus 3, 14. 5 by 14. Plus selecting a third box 1 by 3. And red one 4 plus 3 plus 2, 9. And 4 by 9. So that is 1 by 3 into 7 by 16. Point, you can use the m plus function also. Instead of writing it here, I'll use m plus function. Then 1 by 3 into 4 by 15. 1 by 3 into 4 by 9. Or 5 by 14. Okay. I'll just do it once more. 1 by 3 into 7 by 16 equal to m plus 1 by 3 into 5 by 14 equal to m plus 1 by 3 into 4 by 9 equal to m plus mRC. 0.413, right? I think you're getting 0.413. Please check if the number is correct. Option B is the answer. Okay. Hope it is done. I'll go further. A box contains 5 white and 7 black balls. Two successive draws of 3 balls are made with replacement. What do you mean by two successive draws of 3 balls? Not selecting one, putting it one more, not selecting one, putting it one more, not one by one. Selecting 3 balls together, then put it back and then select all the 3 backs together. So 3 balls, take it, then 3 balls you put it back, again you draw the 3 balls. Two successive draws of 3 balls. So 3 balls at a time. So whenever selection is more than one, we use the concept of combinations. The probability that the first draw would produce white balls and the second draw would produce black balls respectively. So first 3 balls should produce white balls and second 3 balls should produce black balls. Since you're selecting 3 white, so what is, whenever more than one selection, we apply the concept of combination. Numerator, we will have the condition. Denominator, we will not have any condition. So 5 whites and you have to select 3 out of it. So 5C3, this is the condition. Denominator, no condition. 5 white and 7 black balls. So total, you are selecting 12C3. Whenever you select more than one, you use the concept of combinations. Some people will have this doubt. Sir, when it is with replacement, you told we can't do combinations. That I told for one by one. For first 3 balls you're selecting together, you are not selecting one ball, you put it back and then you select one more, you put it back, then you select one more. That you are not doing. 3 balls you are selecting together, right? So when you're selecting 3 balls together, it means for those 3 balls without replacement, individually, one by one I am not doing it. Therefore, I am applying concept of combinations directly to save time. And you select 3 black balls. How many black balls are there? 7C3. In denominator, can you tell me, do we have 12 balls? Should I do 12C3? Or out of 12, in the first situation only, I have taken 3 out. So remaining I should say 9C3. So 12C3 is correct, or should I do 9C3 because you have taken 3 balls out in the first draw. So remaining will be 9. It should still be 12C3 only. Why it should be still be 12C3? Because it is with replacement. I have put the 3 balls back. Had I not put the 3 balls back, had it been without replacement, then you could have told a 9C3. I hope you are able to understand. Anyway, so 5C3, nothing but 5C2 you can say. So 5 into 4 into 3 divided by 3 into 2 into 1. 7C3, 7 into 6 into 5, 3 terms and 3 into 2 into 1. Whole divided by 12C3. 12 into 11 into 10 by 3 into 2 into 1. Same thing. 12 into 11 into 10 divided by 3 into 2 into 1. So 5C3, 5, 4, 3 by 3 by 2 by 1. That is 10. By 12C3, 12, 11, 10 by 6, 220. To 7, 6, 5, 35 divided by 220. 10 by 220 into 35 by 220. 0.05. Is it 4 by 968 or 7 by 968? Ten by 220 into 35 by 220. So how much is that coming to? 10 by 220 into 35 by 220. 0.007 I should get. And if I get 0.007, 4 by 968. I don't get it. 7 by 968. 0.007. So this is what I get, 0.07 matches. So option B. Option B. Okay, I'll go further. A box contains 12 electric lamps, of which 5 are defectives. A man selects 3 lamps at random. What is the expected number of defective lamps in his selection? Before I try, you try first. Let's see if anybody can give me some answer. Anyway, answer should be A, but let's see if you're able to get any of this. Anybody? I see 3. The question is not probability. You have to go till expected number. You know what is expected number? E of x. Mathematical value of expectation. Average, mu. Expected number of defective lamps. Okay, let us solve it. So this is random variable x, which is number of defective lamps. Number of defective lamps. And they are asking expected number. So we have to calculate E of x. Mathematical value of expectation is how much? So how are we going to write? We will have 2 columns. One x column, and then we multiplied by probability x into p. The total is what? We get E of x. X, what I have defined? Number of defective lamps. Now can you tell me what is the minimum number I should write below x, and what is the maximum number I should write in the x column? Take your time, it's okay, but try to think. What is the minimum number in the defective columns column and what is the maximum number in the defective columns. You are selecting how many lamps? You are selecting 3 lamps. Think logically. You are selecting 3 lamps. What are the possibility? All the 3 lamps may be defective. 2 lamps may be defective. 1 lamp may be defective. Or 0. None of them may be defective, right? All of them might be correct ones. So what are the possibilities? That is 0 defective, 1 defective, 2 defective and 3 defective. Defective I am not repeating every time. 0 defectives, none of them are defective. 2 defective, 3 defective. Maximum is 3. I should stop at 3 because you are selecting only 3 lamps. So I should stop at 3 lamps. Coming to the probability of it, we have to calculate the probability. Now, can you give me this combination? Yes, I have to use combination concept. What is the probability of selecting 0 defective? Just give me the number. I don't know the final number. I want the calculation. Like 5C3, 5C2 like that. 0 defectives. Okay, forget about the numerator. Give me denominator at least. You are selecting 3 lamps from the total of how many? You are selecting 3 lamps from the total of 12. So can we say 12C3 is denominator? Denominator without any conditions. Without any conditions, out of 12, you are selecting 3. And what do you want? 0 defectives. You are selecting 0 defectives. How many defectives are there? 5 defectives. So it's going to be 5C0. But you can't stop at that point. You're selecting 3 and among the 3, 0 defective, which means what is the balance ones? You're selecting 3 lamps. There are 0 defectives. But you are selecting the 3. What should be the 3 then? They are all proper ones, right? Non-defective ones. Are you getting it? And non-defective ones are how many? Out of 12, 5 are defectives, remaining is 7. Out of 7, you are forced to select 3 because none of them are defective ones, 7C3. We'll simplify it later. Like this, can you tell me for the next one? Denominator is definitely 12C3 because no conditions. Can you tell me the numerator? You are selecting 1 defective. You are selecting total 3, out of which 1 is defective and remaining is fine, non-defective. So can you tell me similarly, by looking at the first part of the question, what is this going to be? Numerator. You are selecting 1 defective out of how many? From 5 defectives. So it is going to be 5C1. Previously 5C1, 5C0. Now 5C1. And so I multiply 2 normal ones. Out of 3 lamps, 1 is defective. Remaining 2 are normal ones, non-defective. So it's going to be 7C2. 5C1 into 7C2 by 12C3. Again, third one, same thing, 12C3. This at least, can you tell me numerator? You are selecting 2 defective ones and then 1 normal one. That normal one is understood, implied. That also you should consider. Can you tell me numerator? You are selecting 2 defective ones and 1 normal, understood. So it's going to be 5C2 multiplied by 7C1. 2 out of 5 normal ones, 1 out of 7. 2 out of 5 defective ones, 1 out of 7 normal ones. Then 3 defective means 5C3 into 7C0 by 12C3. I'll just zoom it in case if you want to Write it. 5C0 into 7C3. 5C0 into 7C3 by 12C3. 5C1 into 7C2 by 12C3. 5C2 into 7C1 by 12C3. 5C3 into 7C0 by 12C3. And then it's a matter of just calculation. 5C0, that means 1. 7C3, this column I'll write it little later. This x into p column I'll write later. First let me simplify this. So 5C0 is 1. 7C3, 7, 6, 5 by 3 to 1 whole divided by 12C3. 12, 11, 10 divided by 3 to 1. Okay, I don't have space. You have to simplify. I think 12C3 I'll write somewhere because everywhere 12C3 is common. 12C3, 12, 11, 10 divided by 3 to 1. 12, 11, 10 by 3 by 2, 220. I think this 220 is common everywhere. So I'll divide by 220 directly. 5C1 is 5. 7C2, 7 into 6 divided by 2 into 1. Divide by 220 is common. Then 5C2, 5 into 4 divided by 2 into 1. 7C1 is 7. Divided by 220 is common. 5C3 means 5C2 only. So 5 into 4 divided by 2 into 1. 7C0 is 1 divided by 220 is common. So this is 765 by 3 to 1. 35 by 220. This is 7, 6, 21, 21, 85. 105 by 320. 220. 7 into 4, 10, 10 into 7. 70 by 220. 5 into 4, 10, 10, 10 by 220. And as a matter of verification, do the sum of the probability. Sum of the probability should always add up to 1. Check it out. Is it adding up? 35, 105, 70, 10. Yes, 220 by 220. Add 1 is adding up. Now we multiply. X into P. The column you multiply. 0 into 35 by 220. 0 you get. 1 into 105 by 220. 0.4772. 2 into 70 by 120. 220. 0.6364. 3 into 10 by 220. 0.1364. So total 1.25. 1.25. This is the answer. Actually, there is a very good method, but there is a good method which we are going to learn in the next chapter, theoretical distributions, where we have certain formulas. I'll show you when I come to next chapter, but as of now, solve this method. Though it looks lengthy, this is a good revision of many topics in probability and many calculations also we are doing. Probability also we are calculating, expected value also we are doing. So it's a very good problem from concept point of view. Make sure you understand. Don't worry about the timing part. How to solve quickly the same problem, I will tell you when we come to the theoretical distribution chapter. There I have a shortcut. Not a shortcut, good concept. But from understanding basics point of view, solve this in a detailed manner like we have solved. So take your time, go through the solution once more, see if you have any doubts. Is it done? Any doubts on this one? Hope you are comfortable. I'll go further. I hope today you don't need break. I've started slightly later, and if chapter gets over, I'll try to leave early. But I hope it's fine with you. I'll go to the next one. A box contains. Okay, that's what we have done. If x and y are random variables having expected values of 4.5 and 2.5 respectively, then the expected value of y minus x is. This is very simple. E of y minus x, we can write it as E of y minus E of x. E of y is, they have given x and y. E of y is 2.5. E of x is 4.5. So we get minus 2. Now please tell me, should I pick the answer minus 2 or should I pick the answer plus 2? Is it going to be minus 2 or plus 2? Option A or B? Okay, the answer is minus 2 only, not plus 2. Sir, you told ignore minus sign. Where I told ignore minus sign? In standard deviation, mean deviation, range and quartile deviation, measures of dispersion, I told ignore negative. Measures of central tendency, mean median mode can be negative. Central tendency can be negative. And what is the meaning of expected value? Expected value, E of x, mathematical value of expectation, nothing but average. X bar only. Some people say mu. What is that? Mathematical value of expectation, central tendency. So central tendency can be negative. Some people might be confused, but I hope you are clear by this. Central tendency, that is mean, median, mode, is always can be positive, can be negative. So, dispersion, standard deviation, mean deviation, quartile deviation, range, they are always positive. Negative should be ignored. So in life also, always be positive, good for life. But corona positive, not good. So don't think always positive. Be careful. If answer is negative, your marks may be positive. Be very clear on that. Okay, I'll go further. Or just remember somewhere, if you want to make a note of it, you can write it. Measures of central tendency. Mean median mode can be negative, can be positive. Measures of dispersion, always positive. Even if any negative comes, there we ignore. Where? Standard deviation, mean deviation, quartile deviation, and range. Okay, next. Anyway, take a small break of 5 minutes, then we'll continue. Take a quick break of 5 minutes, we'll continue. Take a small break of 5 minutes. Okay, so let's move on to the next one. Okay, so if 2x plus 3y plus 4 equal to 0, variance of x is 6, variance of y is. Now, what is the property of variance? The constant should be ignored because it is independent of origin. And regarding variance, first you should convert it into standard deviation and then calculate and then back to variance. So from the variance of x, you have to calculate standard deviation of x. From the standard deviation of x, you calculate standard deviation of y, and from that you go for variance of y. I hope you know the technique. But if you want to go directly from variance x to variance y, one shortcut I told you. Do you remember the shortcut? We have solved it earlier. When they give you equation, we don't have to follow these big roots. Directly from variance x to variance y I can use with the help of equation, but one activity you should do it. Do you remember that? The coefficient should be squared it. Not 2 square, coefficients. That time it was 2. The coefficient should be squared it. So in this case, what are the coefficients? So we have 2x plus 3y plus 4 equal to 0, and the constant I will ignore, and the coefficients, so 2 I'll make it as 2 square and 3 I'll make it as 3 square. The coefficient should be squared, and x you can substitute it as 6. So 2 square 4, 4 into 6 24, and 9 square y, that is 9y equals to 0. So 9y equals to 24, or y equals minus 24, or minus 24 divided by 9. So 24 by 9, 2.66. I think none of the options are matching. And it's actually plus, ignore minus because variance cannot be negative. So it's going to be plus 24 by 9, or if you express in decimals, 2.666, 2.67. Option is none of this. Coefficient should be squared. That is a shortcut. Hope you remember it. Next. Variable x is the following probability distribution. Obtain standard deviation 3x minus 4. You can follow detailed format, but not required. First, we'll find out the standard deviation of x. Then you know 3x minus 4 is an equation. Ignore the constant, ignore the minus sign. For standard deviation, substitute, you get the answer. So first we'll compute the standard deviation of x. So x is given by 4, random variable 4, 5, 7, 8, 10. Then probability 0.15, 0.20, 0.40, 0.15, 0.10. Total should be 1. 35, 75, yeah, total is 1. And what order we require? Standard deviation of x is going to be square root of variance. Or if you know what is the formula for variance, I told you. Easy method when full-fledged form like this. It's going to be e of x square minus e of x the whole square. Square root. This answer is variance. You take a square root, you get standard deviation. E of x means x multiplied by p. E of x square, I am going to need x square column and then x square column multiplied by p. This will give me E of x square, expected value of x square. And in fact, you can do this without writing it directly in the calculator. You can do with the help of m plus MRC. Anyway, whichever method you follow, can you tell me what is the standard deviation of x? Please try fill up these three columns and use this formula, and you tell me what is standard deviation of x. Once you find out the standard deviation of x, then we'll find out standard deviation of 3x minus 4. That we'll do later. First you try, you please calculate standard deviation of x. You can also do 3x minus 4, but let's follow this method. First we'll find out the standard deviation of x, then we'll use the property, we'll find out 3x minus 4. Ignore the constant, ignore the minus sign using that concept. But can you please tell me, first of all, how much you get standard deviation of x? Okay, uh, I'm not getting any answer. Let me do it. 4 into 0.15, 0.6, 5 into 0.2, that is 1, 7 into 0.4, 2.8, 8 into 0.15, 1.2, 10 into 0.10, 1. So this is what is E of x. Point 0.6 plus 1 plus 2.8 plus 1.2 plus 1, 6.6. X square, 4 square 16, 5 square 25, 7 square 49, 8 square 64, 10 square hundreds. Then x square into p, 16 into 0.15, 2.4, 25 into 0.2, 5, 49 into 0.4, 19.6, 0.15 into 64, 9.6, 0.1 into hundreds, 10. And total 46.6. This is E of x square. So I'll use the standard deviation formula, square root of E of x square, which is a 46.6, E of x the whole square, 6.6 square. So 46.6 is fine, 6.6 square, 6.6 square minus 46.6, then square root. $1.74. 1.74. And we need to calculate for 3x minus 4, right? Standard deviation of 3x minus 4. We ignore the constants independent of origin. So we ignore the constants. And the 3 multiplication we do. So 3 into 1.74. So you multiply it by 3. You get 5 points to the 1.74 into 3. 5.22. 5.22 we get, is it? Okay. 5.22, I can't select 5.12. So none of this. None of this. Okay. Let me go further. Following are the wages of 8 workers in rupees. If one of the worker is selected random, what is the probability that his average wage will be lower than average wage? So first you calculate the average wage. Add all 50 plus 62 plus 40 plus 70 plus 45 plus 56 plus 32 plus 45 divided by 8. 50 plus 62 plus 40 plus 70 plus 45 plus 56 plus 32 plus 45 divided by 8. I think you get 50 as the amounts. 50 is the number, average. And you want to know how many people are below average, below 50. So you get 40, 45, 32, 45. So basically there are 4 people below average, 4 workers, 4 workers below average. When we say average, we take arithmetic mean only. So 4 workers below average out of 8. And asking probability. So 4 out of 8, 4 by 8, 0.5. 0.5. Next. If all the values taken by random variable are equal, then which is correct? Expected value is 0, standard deviation is 0. If standard deviation is positive, standard deviation is real number. If all the values taken by random variable are equal, if all values are same, what deviation you get? If the numbers are 8, 8, 8, average also 8 you get. When you do deviation 8 minus 8, you get 0, 0, 0. So deviation when you calculate, everything is 0. Standard deviation when you calculate also will be 0. In fact, if everybody is same, what is the difference? Everybody is same, no difference. So when everybody is equal, standard deviation becomes 0. So if all the values are random variable means x value. So if all the x values are equal, that means standard deviation is 0. Standard deviation is 0. Next. A bag contains 6 white and 4 red balls. If a person draws 2 balls and receives rupees 10 and 20 for white balls respectively, his expected amount is. First of all, please tell me, what do you mean by expected amount? What we should calculate? Should I calculate a probability or should I calculate E of x? Expected amount. Expected amount means expected value, E of x. First, you should identify that. And E of x means 2 column will come. 1x, 1p, you multiply, that's how we get E of x. Now, a person draws 2 balls. Now, can you think, when you draw 2 balls, and there are white and red balls, what are the possibilities you can think of? For example, if you toss a coin 3 times, all the 3 can be head, 2 can be head, 1 can be head, 0 can be head. Like that, can you think and tell me, when you draw 2 balls, what are the possibilities that can happen among those 2 balls? One possibility, both are white balls. Second possibility, both are red balls. Third possibility, one white, one red. Three possibility, right? Total 3 possibility. So both are white, both are red, or one white, one red. So let us draw the possibilities. Possibilities. Both red, both white, and one red and one white. One red and one white. This is possibilities. How much amount you get if both are red? See, you get rupees 10 for white ball and rupee 10, 20 for red balls. So what is the value? X random variable you get. Both are red. For one red only you get 10 rupees. No, red you get 20 rupees. So 20 plus 20, 40 rupees you get. Both white. For one white you get 10 rupees. Now white and white you get 10 plus 10, 20 rupees. One white, one red, 10 plus 20, you will get 30 rupees. These are the possibilities. Then we'll take the probability. Now both are red. When you're selecting 2 balls, selection more than one, we apply combination. Numerator will be with condition, denominator will be without restriction, without condition. In this case, first of all, let's fix what is denominator, then we'll go for the numerator. So in this case, what is going to be denominator? Forget about red and white. You are selecting 2 balls from total how many? Total 6 plus 4, 10. So denominator without any restriction is going to be 10C2 in each case. Without any restriction, that is denominator, that is sample space. Numerator condition. What is the condition? Both are red. How many red are there? 4. So you have to select 4C2, 2 red from 4 red. Then both are white. We have 6 white. Both are white. 6C2. Then 1 red, 1 white. So 4C1 into 6C1. 1 each. And 1 red and 1 white. So multiply. 4C2. 4 into 3 divided by 2 into 1. 10C2 is common everywhere. So I'll calculate somewhere. 10C2. 10 into 9 divided by 2 into 1. I think you get 45. So 45 will divide everywhere. 6C2. 6 into 5 divided by 2 into 1. 4 into 61. That's simple. 4 into 6. Divide by 45. Divide by 45. So this is 6 by 45. This is 15 by 45. This is 24 by 45. And ensure total is 1. 30 plus 15. Total is 1. Yes. Then you do x into p. Expected value. E of x. 40 into 45. Sorry, 40 into 6 by 45. 5.33. 20 into 15 by 45. 6.66. 6.67. 30 into 24 by 45. 16. So E of x, expected value 28. Option D. Okay, I'll go further. Initially, probability was a branch of mathematics. Initially, now we have a separating statistics, but initially it was part of mathematics. An experiment known to be random, if the results of the experiment cannot be predicted, output should be unknown. If you know, that's not random. So if it has to be random experiment, then output should not be predicted, output should not be known. So output result cannot be predicted. You don't know in advance. So option A. Probability of A equal to probability of B, then A and B are same events, must be same events, may be different events, are mutually exclusive events. Okay, this is a very tricky question. You have to be odd man out in this case. Can option B be correct? Are same events? Not necessarily. Probability is equal. They may be different events. The probability of head, the probability of tail. Must be same events? Definitely not. They may be different. Mutually exclusive? Not necessary. There is, so if by taking the three options out, our answer is option C. So basically it means they may be same events, they may be different events, but their probability is same. But the actual events may be same, may be different. So the closest answer we have is option C. May be same, may be different, but their probability is equal. But their events are not equal. Events are not same. Events are different. Maybe different. I don't know. Maybe same also. So option C is the closest appropriate one in this case. If for events A and B, probability of A union B equal to 1, then A and B are called as exhaustive events. Why? Because probability is equal to 1. Probability equal to 1 means it will happen, sure event. It will happen. Either A will happen or B will happen for sure. That means it is sample space, exhaustive events. Head and tail. Probability of A, probability of B, 1 by 2, 1 by 2, total is 1. So when one of the events has to occur, if somebody asks, what do you think will happen to exam? Either I will pass or I will fail. One of them will happen for sure. Exhaustive events. And their probability is 1. Sure. Okay. Next. If unbiased coin tossed once, then the two events, head and tail, are mutually exclusive. Answer is yes, because head and tail cannot happen, both of them. Exhaustive, yes, one of them will happen, either head or tail, or exception situation is when Rajnikant toss, it might stand. Otherwise, head or tail will happen. Exhaustive. Equally likely, yes, probability of head is also 1 by 2, probability tail is also 1 by 2. So all are correct. All these A, B, C. Option D. If probability of A is probability of B, then the two events A or B are independent, dependent, equally likely A and C. When the probabilities are equal, the independence does not come. They may be independent, they may be independent, that we don't know. But they are equally likely. Their chances are same. Their probability is same. That is equally likely, option C. If two events A and B, probability of A intersection B is probability of A into probability of B, then the two events A and B are this. Can you tell me? Intersection is obtained by A into B by multiplication. When do we do it? When the events are independent. When the events are independent, the intersection can be calculated by multiplication. A. If ABC are mutually exclusive and exhaustive events such that probability of A is equal to probability of C, then what is probability of B? Okay. Now, can you please tell me what is the importance of mutually exclusive? What is the importance of mutually exclusive? Or what will happen to intersection sets? A intersection B, B intersection C, A intersection C. What will happen to those intersection sets when they are mutually exclusive? They will be 0, right? Mutually exclusive means they cannot happen simultaneously, and they cannot happen simultaneously means the intersection probability, intersection sets probabilities are 0. And exhaustive events, exhaustive event means they will happen. So probability of A union B union C, if I write, what is the formula? Probability of A plus probability plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C plus probability of A intersection B intersection C is the formula. But because mutually exclusive events, these are all 0. Intersection probability is 0. Then A union B union C should be equal to 1. Exhaustive events, sample space will happen. That means it is sure event. So union set probability in this case is 1. Not every time. In this case it is 1. And they said probability of A is equal to probability of B is equal to probability of C. So this is like solving your x value or ratio problem. Anyway, let's write it down. Probability of A equals to probability of B. What I am going to write, probability of A, I will rewrite. How? 2 into probability of B. Just now I showed you probability of A is into 2 into probability of B. Similarly, I will use this one, 2 into probability of B equals to 3 into probability of C. Now, I can either simplify in terms of B or I can simplify in terms of C. But what I want, what is the requirement, what is probability of B? So what will I do? I will express in terms of B. I want to calculate in terms of B. So I will express in terms of B. So probability of C equals 3 comes denominator. It is 2 by 3 probability of B. I have expressed in terms of B. Whichever I want to calculate, it has to be in those terms. So probability of A, 2 into probability of B. Probability of B, probability B as it is. Probability of C, I am rewriting it as 2 into probability of B divided by 3 equal to 1. Take LCM, multiply 3 into 2, 6 probability of B. This 3 into 1, 3 probability of B. 2 as it is. Probability of B equal to 1 divided by 3. So 6, 3 plus 2. 11, right? 11 probability of B equals 1 into 3 is 3. So probability of B equals 3 by 11. So 3 by 11, you get option B. This is more of a mathematics question, but anyway, you please write it down. Okay, next. If probability is 0.6, probability of B is 0.4, probability of C 0.1, what is probability of A intersection B intersection C? Assuming events are independent. This can you tell me? Very easy one. Independent events. And you have to calculate intersection. Intersection of independent events can be calculated by multiplication, product. So 0.6 into 0.4 into 0.1. 0.04, that's all the answer. Next one. Probability of A slash B is equal to probability of A, then A is independent of B, B is independent of A, B is independent of dependent of A, both A and B. Now please tell me. P of A means what? Probability of A. Correct. What is probability of A slash B? Probability of A slash B means what is the probability of A given that B has already occurred? Now look at the probability. Both are equal. Which means what? Whether B occurred or not, probability is same. Probability of A is so much. And probability of A after B happening is also same thing. So whether B is happening or not, probability of A remains same, which means basically A is independent of B, and A is independent of means B is also will be independent of A. It will be vice versa in terms of events. So both are A and B. I'll explain once more. Probability of A is probability of A, event A. And A slash B means what is the probability of A given B has occurred. Observe, B has occurred, that probability, whether B occurred or not, that probability is same. Which means the probability remains same even after B. If I want, I'll write down sentence. Probability of event A remains same even after event B occurred. This is like telling this. Even if Virat Kohli leaves, RCB will lose. I mean, this is an example I'm telling you. Probability of event A will same even if whether other event happens or not. Our probability does not change. Or I will tell other way around. If RCB wins, will you pass in exams? And RCB loses, will you pass in exam? Does not depend, right? Whether RCB win or not, your examination chance will not change. You have to read for exams and you have to write the exam. That means to say that two events are not dependent, independent. Anyway, so option C. That is option D, sorry. Both are independent. A is independent of B and they are independent of each other. That's what it means. Let's go further. If two unbiased dice are rolled together, what's the probability they are getting no difference of point? No difference means what? 1, 1. Difference is 0. 2, 2. Difference is 0. 3, 3. Difference is 0. 4, 4. 5, 5. 6, 6. So there are 6 possibility. Out of total how many? When you roll a dice together, one event can be done in 6 ways. Second one can be in 6 ways. So total possibility 36 ways and we are finding total is 6. So 6 by 36. 6 by 36 is same as 1 by 6. This and all you should solve the exam question in fraction of second. Should not take time at all. 1 by 6. 6 by 36. That is 1 by 6. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So 6 possibility. Out of total 36 possibility, 1 by 6. If two events are independent, then their complements are also independent. That's what it means. If the two events are independent, A is independent of B, B is independent of A complement is independent of B complement is independent of A, and A complement is independent of B complement. If A and B are independent, everything is independent. So all of these, option D. If two random variables y equals to 2 minus 3x, then standard deviation of y is given by. Can you tell me which is the right option? Standard deviation is independent of origin but dependent on scale and cannot be negative number. And when they give you equation for standard deviation, we ignore the constant, we ignore the minus sign. Ignore the constant, ignore the minus sign. So what remains is 3x, that is 3 into standard deviation of x. That is option B. Why C, my dear friend? It is standard deviation. If it was variance, then you told 9x. 3 square you should do. I have not asked variance. Only variance, the coefficient should be square as a shortcut. And if it is for mean median, nothing to ignore. Everything will come. Anyway, hope you got it. Next. 2 balls are drawn from a bag containing 5 white and 7 black balls. What is the probability of different color? What do you mean by different color, my dear friend? Can you try this problem quickly? You are selecting 2 balls from black and white. And what is the probability of selecting would be different color. Different color means 1 white, 1 black. So numerator 1 white, 1 black. Denominator anything, no conditions. So what is denominator? You are selecting 2 out of total how many? 12C2. And numerator 1 white 1 black, 5C1 and 7C1. So 5 into 7 is 35, 12C1, 12 into 11 by 2, 11 into 6, 66. So 35, 66, option A. I hope you are able to get this, not a difficult one. I'll go next. If two independent events A and B, A union B is 2 by 3, probability of A is 2 by 5, what is probability of B? This you please try. I'll give you 2 minutes. Please try. Okay, let me solve it for you. For two independent events, I hope you know what is two independent events means. That is the properties A intersection B written as probability of A into probability of B. Let's use the formula. Probability of A union B is probability of A plus probability of B minus probability of A intersection B. You have to know the formula. A union B is given as 2 by 3. Probability of A is also given as 2 by 5. Probability of B not given. Let me assume it as X. And A intersection B, I am going to use probability of A into probability of B. Probability of A is given as 2 by 5. Probability of B, I don't know. I am taking it as X. And we have to simplify. You will get the value of X. This I'll bring it to left side. So 2 by 3 minus 2 by 5. This is X minus 2 by 5. 2 by 5. Okay, let me simplify fractions. 2 by 5. I'll cross multiply. That becomes 5. Okay. X minus 2 by 5. I'll simplify. 5 into 2, 10. 3 into 2, 6. 3 into 5, 15. 5 into x, 5x minus 2x divided by 5. So I can simplify. 5 ones are, 5 threes are. Then 10 minus 6 is 4. 3 into 5x minus 2x is 3x. 3x into 3 is 9x. So 9 goes to left side. X is 4 by 9. This is just simplification. I hope you understood. Or if you make decimals also fine, my dear friends. If you don't like fraction simplification, make it decimals. You will get the answer. I'll do quickly fractionals, decimals for those who are not comfortable with fractions. 2 by 3 minus 2 by 5. So if I do it in calculator, 2 by 3 means 0.67. 2 by 5 means 0.4. So 0.67 minus 0.4. So this is 0.27 when I simplify in decimals. And this is 1 minus 2 by 5. 2 by 5 is 0.4. So 1 minus 0.4 means 0.6. So 0.6x equals 0.27. So you do 0.27 by 0.6, 0.6, you get 0.45. And what is the answer? 4 by 9. You get 0.444, round it up, 0.45 you'll get. So that's how you can select option B, 4 by 9. So even if you're not comfortable with the fractions, you can make it decimals, you will get the closest answer. When you're doing decimals, remember you have to select the closest one because the rounding off will be there. So there you don't tell, sir, we are getting 0.45, but 4 by 9 is 0.44, not matching, sir. When you're doing rounding, when you're doing decimals, rounding off will happen. So you should select the closest one. Next. Probability of A is given, probability of B is given, probability of A slash B given. What is probability of B slash A? Okay, what is the formula? Probability of B slash A means probability of A intersection B, denominator should be 1. Whichever event already taken place, this one. Probability of A should be denominator. Now probability of A is available in the problem. Probability of A intersection B not given in the problem. Sir, can I multiply? No, they are not independent events. They have given A slash B. So probability of A after B has occurred, answer will change. They are not independent events. They are dependent events. So we should calculate. How do I calculate? I'll make use of the other one. Probability of A slash B, probability of A intersection B by probability of B. Probability of A slash B is given 2 by 3. Probability of B is given, which is 3 by 4. And probability of A intersection B, I can calculate. So this 3 and 3 gets cancelled. This 4 goes to the numerator. So 4 probability of A intersection B is equal to 2. So probability of A intersection B is 2 by 4 or 1 by 2. So A intersection B is 1 by 2. Probability of A is 2 by 3. And 3 denominator of denominator goes to numerator. And this 2 comes down. So 2 into 2, that becomes 4. So 3 by 4. Remember, when they give you things like this, see probability of A independent separately is 2 by 3. But after B has occurred, oh, 2 by 3. Oh, it's independent events only, is it? Arre, you could have directly calculated. No, answer is 3 by 4. Logically. Anyway, you write down. I'll tell you the logic once more. So many calculation was not required. You could have done the logical method. But anyway, if numbers were different, this method process would be required. Take it down. Okay, now let me tell you the logical one. You see, probability of A is 2 by 3. And probability of A slash B is also 2 by 3. And what do you understand by this number? Probability of A is 2 by 3. And after B has occurred, probability is still the same. Even after B occurred, probability of A did not change. Can you tell me what do you mean by that? What is the interpretation of that? Probability of 2 by 3. After B occurred, still remained. Probability did not change. Even after occurrence of B, A did not change. That means events are independent. Probability are same. A or A slash B, events are independent because of equal. When those two are equal, if A is independent of B, B is also independent of A, vice versa. So probability of B is 3 by 4. So probability of B slash A also will be 3 by 4 only. Which means the one event is not having a impact on another event. But anyway, don't worry. We have calculated this one. If numbers were different, you had to follow this process. We have done it. But anyway, understand the logical method also. Okay, let me go for the last one. Probability of A is A, probability of B is B, probability of A intersection B is C, then expression of A complement intersection B complement in terms of ABC. What is A intersection B complement? 1 minus of this, right? What is probability of A complement intersection B complement? It is like neither of them. 1 minus probability of A union B. A union B complement basically, right? Probability A union B complement. That's what it means. 1 minus A union B. Probability of neither is 1 minus probability of either. Probability of at least one is 1 minus probability of neither. Hope you remember. We have done quite a few problems. And what is the formula for A union B? Probability of A plus probability of B minus probability of A intersection B. They are not independent events. They have given some numbers, values. So probability of A, they say take it as small a. Probability of B, they take it as small b. A intersection B, take it as C. So open the brackets. 1 minus A minus B plus C. Minus into plus is minus, minus plus minus, minus into minus plus. So 1 minus A minus B plus C. 1 minus A minus B plus C. I think option D. Yeah, option D is the answer. Option D. Okay, that's it. Homework problem answer keys, please take it down, take the screenshot. We will discuss the answers, whichever you have doubt. Homework problem answer keys, please take a screenshot. Probability chapter. Okay, so that's it for today's class.